I just need to add a couple of extra things to the video which probably weren't well explained by me. When we were talking about controller config, I mentioned that all the settings that used to be in here have changed. So for example, when we have a look at controller mode, there was a lot of settings there, and I did mention that they moved to the defines folder, but I probably needed to be a bit clearer in this. So of course that has to do with access point defines would include the IP address and the SID and password, and for station mode it would be underneath station mode defines. So there's your SID and password information, your static IP information, etc. So when you're looking at a particular service, including MQTT, MQTT you can also access via the management server. So for example, here are the default defines which you can change. But the thing is, with the passwords and SID information and stuff like that, that information you can't change in the management server for obvious reasons, security being the main one. So these password details, etc., they are stored in the defines files, and if you needed to change them, you have no choice at the moment but to reprogram the controller. So that's where you can find them, where you can change them before you program the controller. Right, next up, I wanted to and some other things that I wanted to explain. This of course is the management server, and of course the username and password is admin, and of course that information would be found in the management defines file. Here it is here, the username password. Right, so I wanted to do a little demo of the management server. So let's go into here, let's sign in, and in this particular tab I'll open up access to the web server. So this is the information coming from the web server. So back in the management server we can actually change things around a wee bit. So let me just stop it. Let me change the port to 8080, because you can't change it when it's running, of course. And let me restart it. And coming back over to here, if I then refresh the page, remember the default's port 80, and so you can immediately see there's no response. But if I now type in the new port number, which is 8080, you can see that the information is readily available from the web server on the new port. So it's very easy to change these services, stop these services, and start them again, and that includes virtually all the servers that are on there. Okay, there used to be some issues concerning rebooting the controller, and they're purely cosmetic. So what we have, I'll just leave this running up here so I can access it through the window in a moment. I can do this, reboot the controller. We get a message box saying, are you sure? Yes, I am. And we can, the controller will reboot. You can see it just rebooted there in the serial log. And when it comes up and it's actually running, what we're going to find is this will come back to admin page 1. And there we go, the server's up and running again. You see the tasks are running, nothing's changed. Remember, I changed the web server port back to normal. You can see it just updated. So everything comes back fine now. Right, the web server, of course, supports a whole lot of different commands. So you can go /commands on a web server. It comes back and it says, oh, okay, I accept all of these types of commands. This is the JSON ones as well. And so, for example, BA returns humidity. So if I did this, BA, that's the humidity value that's come back. Sorry, the ambient value is BA. Right, there were a few changes to the web server, and it really had to do around, first off, MQTT. And you can see here that a number of the calls were changed. So you've got a subscribe or enable state which is currently off, which matches, of course, let's go down to the MQTT page, and of course I've got subscribe enable disabled. So that's about it. NTP was changed to accommodate the fact that RTC sync NTP time interval is now gone. And last but not least, TSL used to be TSLCF, and because we added a few more things, changed the name to TSL, and TSL returns the sample size and the averaging, whether it's enabled or not. And this returns the last received GGA message from the NEM controller, and of course there is no controller enabled in this. I've got it disabled. So what does that actually look like? Good question. Just drop out of there, come into here. We're on the web server and we want a GGA message. This is the actual response now. Of course I've blanked out the actual raw locational data from that, but this is a typical response for GGA when you've got a fix. So you can see immediately what the GPS sensor is coming back by using GGA, GLL and RMC type messages, and you can view them straight from the web server. This is the web server, and just to show you that it's reasonably safe to do things, if I tried to access the admin pages, you can see that it's not possible to access the admin pages direct from the web server. You just can't do that. Some people were asking what does MQTT keep alive do? Notice here on the MQTT client that we're using has the ability to go and just check its connection with the MQTT server all the time, and that period of time is defined by the value in the text field, which is anywhere from 50 to 180 seconds. And I don't sort of advise playing with this stuff, because I found that 15 seconds works really well. Something that I wanted to talk about was in fact the TCPIP server. I don't think I demonstrated this, so I will now. This server responds to commands that it receives on port 2121. Examples of that are, for example, when you use the mysqmplus Windows app or the ESCOM OC or the Linux apps, it uses that port number 2121 to speak to the controller. Okay, so you can see that it's connected and speaking to the controller. And in version 128, I changed this. We originally started out with a maximum of 4 possible connections. Along the way it sort of got dropped. But for instance, if you've got another app which can speak TCPIP on port 2121 and send the right commands, and I think I demonstrated this before, you notice now that I've actually got 2 clients connected to the TCPIP server. They're both connected, and it means that if I do something on one, it should affect the output on the other. Let's just type in the trusty 0, click send, and it's giving me the system time information back. And if I pulled up, just bear with me for a second. Protocol. Oh, sorry, didn't want the word one. Let me pull up the PDF of the protocol one, and something that's going to be obvious. Okay, so we'll do this one, 034. So here am I on the BME sensor, and the altitude at the moment is 30.2, and I know if I send the code 034 with the number, I'm going to be able to change it. So I'll do that in my query app. So I want to send 034 plus a floating type number. So let's make it 55.7 meters above sea level and terminate it with a hash. I'll send that off to the TCPIP server. And let's go back to the Windows app, which is this one. And so we would expect this to change to 55.7. And there it is, 55.7. So it shows you that we can have up to 4 multiple connections at once. So you can actually run a TCPIP logger as well, getting stuff at the same time as you're using these apps. Last but not least, I'll talk something about debugging aids. Now every single file has got one of these towards the beginning, which says debugging local to this file. And if you enable this, of course, then those debug messages would be coming out to the serial port. And I don't recommend that you play with any of the debugging unless, of course, there's an issue. So in every single page, etc., code, it has its own. But there are also, in looking in mydefines.h, and I'll scroll down towards the end because this is where it happens, we have got 5 basic types of error messages or debugging aids. The first is init message debug, and that sends out, like for example, when we initialize a BME 280 sensor, or we start a service or whatever. And we have information messages which provide some level of feedback. We have warning messages, and these warning messages say, hey, something went wrong, but it's okay, I can fix it. The error messages, well, something drastically went wrong and we didn't expect that, and what should we do about it? And last but not least, we have runtime codes. So those are the levels of messages that are available on the controller. And what I want to do now is I want to have a look at some of these runtime codes. So let's start up this and go back to so my brain got lost there for a moment. yeah, we're talking about debugging codes. I'll be looking in here, and I'll be looking for something called runtime. Oh, sorry, I know where it is now. In here, runtime codes, and so this is in the root folder of the when you unzip the firmware file. So let me just pull this up. So these are runtime codes. They're basically 3-digit characters followed by a number, and you see there's a whole heap of them. And these runtime codes, if they're enabled, will be output to the serial port. Right, so these error codes, and I've just enabled some, and I'm reprogramming the controller with those changes because obviously I turned them all off when I posted the firmware zip file, and so I was getting nothing output on the serial port, but this will fix it. So these various levels do certain things in terms of providing you information and feedback on what's going on. You shouldn't really run a production system on these at all, but the runtime codes is quite handy. So what I intend to do is I intend to show a number of things associated with this, and let me just start up a serial logger and have that ready while we're waiting. It's now writing that information, so let me switch to the serial port monitor, which is from the Arduino IDE, and you start seeing what I mean. So we've got init messages, see this? We're initializing station mode, we're starting the TCPIP server, we're starting the NTP client, we're starting the management server. So these are all the info and messages that are coming through. And with runtime codes, let me just switch to there. You notice they're all 3 digits long, 3 characters long, followed by a digit. And so I'm looking at here and I'm going, oh, okay, there's MSB0, WSB0, okay, WS0, let's have a look. WS0 is the starting of the web server. TTR 0 is starting the task timer. Okay. WS, that's the web server starting. And here we've got some other codes, MSB2. So looking at the code, management server, where are we? Management server, and I scroll past all this stuff, getting down to where it actually starts up, etc. So here we go. So that's the start, this is the stop, this is the release, which allows you to recreate it. And this is the dot loop function, which has to be called by main. So way down in the main stuff, under a case state, we will call this function here it is here. This is the function which is called within the main loop. Every time the main loop executes about 1 millisecond or less, web server loop is called. And when we go back to the management server, this is it here. It gets redirected to loop. And so what happens is, what it does is it checks to see whether or not there's been a request from a web client, and if it does, it processes it. And I put in a little counter here from 0 to 7,500, and when it reaches 7,500, it prints this message MSB2, so MSB-2, which means that that loop has been executed 7,500 times. And you get these messages MSB. Let's go back and have a look. Here was at 38, and then it happened at 53. So that's about 15 seconds apart. So within 15 seconds, you had 7,500 calls to this loop. And of course, the TCPIP server has a loop, and the web server has a loop, and they're all, here's the web server loop, etc. So it provides meaningful feedback on whether or not something's happening. And as I said, you can use these particular codes by looking up what the equivalence would be from the runtime codes text file. Right, so what I'm going to do is MQT7, which just occurred there, is in fact a publish statement to an MQTT broker. So I know that I'm publishing messages. I'm going to stop that, and I'm going to start this one up now. And what this basically does is keep a log of everything that's written to the serial port by the controller. So we've just had a web server loop and so on. So it's just going to go there and keep collecting messages, and meanwhile I can go back and do other things. Right, so last thing I want to talk about the Watchdog Timer, and I'm in the main firmware file, and this is what includes the Watchdog Timer. And then at the end of setup, as we don't want it starting, this Watchdog Timer starting before we start all our services and stuff, we want it to be the last thing that started in setup. So we're just about there. Here we go. Watchdog Timer start. So what happens with the Watchdog Timer is it's a special counter and interrupt pair, if you like, that is controlled by the ESP chip itself, and we can basically say, hey, start counting, and we give it an interval time, and the interval time is WDT underscore timeout. This has been defined as 30 seconds, so it's in seconds. And what it does is it initializes the Watchdog Timer and sets a count maximum value of 30 seconds. And this Watchdog Timer then starts its own internal counter starting from 0. And if that count value ever reaches 30 seconds, it causes a panic reboot, complete shutdown of the ESP and reboot of the chip. Right? And I'm telling it to, when I pass a null parameter, I'm asking it to watch our particular code that we're running. So away it goes, and we start up the main loop, etc. This special line at the beginning of loop means every time loop is called, and loop is sequential, so you start in loop and you finish at loop, and then you keep repeating until something basically gets turned off. So this command, what it does is it tells the Watchdog Timer to reset its counter to 0 and start counting back up to the maximum value of 30 seconds again. So as long as we keep telling the timer to reset itself and start at 0, that panic boot will never happen. If there's a bug and it gets caught up somewhere in MQTT or some other extraneous place, that watch and doesn't come back to loop, then the Watchdog Timer, which runs independently, will count to 30 and will generate the panic reboot, and the whole system will shut down and restart. And the panic reboot information is actually outputted to the serial port when a panic boot occurs. And so this is why I've been running this serial logger here, is just to catch the codes that's going through, because the panic reboot information, if it expires, the panic reboot information is written to the serial port, and then I can use something like an exception debugger to actually find out what happened. So in D, this is the serial logger output, and so as you can see, it's been logging happily away from 7:51 at night and so on. So that's I can just leave that running as ad infinitum, if you like, for as long as something happens. And when something happens, I will get a panic reboot, and then I can use something like this, exception decoder, and I can paste all the panic reboot information into here, and possibly, if it's working well and likes what you do, it'll it'll print what happened which caused the panic reboot, in other words a backward stack trace.